Hello everyone. So this is Pre-Calc lesson 42. We have conic sections, circles, and constants in exponential functions. Conic sections, this is just kind of a quick little overview. We're going to be doing a lot more with conic sections later, but this is your first introduction. So what is a conic section? It's a circular cone like this, generated by a line where one point is fixed. So the fixed point is here. This is our line. And another point, like we move this around a circle. So the line is taken like this and moved around a circle, and that creates our conic section. Now, our circular cone. A conic section is formed when one or both napes, so these are the napes, are cut by a plane. So if we slice it this way, or we touch just part of it, that is a conic section. Now we have these four different conic sections we're going to talk about: a circle, ellipse, parabola, and hyperbola. Okay, and they look like these. Particularly, we are going to talk about circles. So the definition of a circle is the locus of all points in a plane that are equidistant from a point called the center. Okay, so the standard form of a circle is x squared plus y squared is r squared. Now this has a center of 0, 0, and a radius of r. Okay, now what we are going to do is let's first derive a different kind of formula for circle. So let's do an example. Find the standard form of a circle whose center is HK and radius R. So if I was to draw this is my circle, this is HK, and this is my radius R. Okay, now it is something where all the points are equidistant, which means they all have a distance of R. So if I do the point, let's do the distance between HK and the point X. So X minus H squared plus Y minus K squared equals R, right? This is saying that the distance between all of these points is equal to R, which is our radius. And if we square both sides, we get X minus H squared plus Y minus K squared is R squared. That is the equation for a circle who has a center of HK and a radius of R. Now, the standard form that we had, x squared plus y squared equals r squared, that had a center of 0, 0. This is what we will use if we have a center of HK. So, let's do another example. We want to find the general form of the equation of a circle with center negative 3, 3 and radius 4. And we want to draw a sketch. So I'm going to draw my sketch first. So I have negative 3, 3. And my radius is 4, so I go 4 in every direction. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. Connect those dots to the best of your ability. Maybe your ability is better than mine. Okay, there's my circle. And I know it's going to be, this is HK, so it's going to be x minus h, which is negative, squared, plus y minus k squared equals r squared. That is the formula for the equation of a circle with center negative 3, 3 and radius 4. All right, so let's talk about exponential functions. Quick recap. The power is a variable, okay? And for all exponential functions, the exponent has a variable, and the base is a positive number, except 1. Okay? And for the graphs, if we have a whole base, our graph will be like this, going through 0, 1. And if we have a fractional base, our graph will look like this, also going through 0, 1. Okay? That's a quick recap. Now, let's look at if things change. So first, let's sketch the graph of y equals 3 to the negative x. Okay, we should already have an idea of what's going to happen. Okay, because when we have the negative inside of the x, we know that we are reflected across our y-axis. So I'm going to draw a sketch first. So we know that this is approximately 3 to the x. Okay. Now, we know that the negative x is going to reflect us across the y-axis, which would look like this. Y equals 3 to the negative x. Which also we can relate to y equals 3. Let's rewrite it as 3 to the negative 1 to the x, which 3 to the negative 1 is 1/3 to the x. It's the same graph. So now let's actually graph it. We know it's going to go through 0, 1. Okay, and if we do our xy chart, we're graphing the same thing, 3 to the negative x, or 1/3 to the x. So I know if I plug in 0 for x, I get 1. If I plug in 1 for x, I get 1/3. 2, I get 1/9. So we're going down like this. If I plug in negative 1, I get 3, and negative 2, I get 9. Negative 2. Do 9 up here. And there we have it. There's my graph. Y equals 3 to the negative x. We've reflected over the y-axis. Okay, let's do example 4. Y equals 1/2 to the 2x. Okay, so again, we could rewrite this as 1/2 squared to the x, which really is 1/4 to the x. So let's create our xy chart for that. We know it goes through 0, 1. We know it's 1/4 to 1/16. Let's do negative 1 and negative 2, gives me 4 and 16. Negative 1 and negative 2. Okay, so 1/2 to the 2x makes it a little steeper, right? If we had 1/2 to the x, we would be a little shallower this way, but 1/2 to the 2x makes it a little steeper. All the same thing that happens in regular graphs with our functions and translations. Okay. Let's look at this last example. 1/2 to the negative x minus 2. So what this tells me, what I'm going to do, okay, is we have a negative x, which is the same thing, right? I can rewrite this. I'm going to pull out the negative to x plus 2. The negative reflects us across the y-axis, and the plus 2 moves us left 2. Okay? so let's see what this looks like. Now you can plug in, do your XY chart. If we plug in 0 for x, normally we would get 1, but now if we plug in 0, we get 1/2 to the negative 2, which the negative flips it over, gives me 4. So now I go through 0, 4. I've moved to the left 2. So then let's plug in a negative 2. I would have negative 2 plus 2 is 0, so 1/2 to the 0 is 1. So normally where I would go through 0, 1, I've gone through negative 2, 1 because I've moved to the left 2. And normally where 1/2 x would be going this way, I'm going exponentially positive or increasing because of this negative. I've reflected. Okay, let's do one more. Let's put in, I don't know, 1. So we get negative, so 1 plus 2 gives me 3, so y equals 1/2 to the negative 3, which gives me 8. Here. And there you have it. There's my graph. All right, that is all for this video. Hope you have a great rest of your night, and we will see you tomorrow.